So here we have the very first speed made good problem in your book. Page 28, speed made good. First question says, at 2016, your position is, gives me a latitude and longitude. At 2128, your position is, it gives me a latitude and longitude. What was the speed made good between the two positions? So at the end of the day, the answer is a speed. So anytime I'm doing a speed made good problem, I'm going to start by drawing the triangle because it's going to help me to solve the problem. So the triangle, the D Street triangle, or daylight savings time triangle, kind of helps me figure out which formula to use. So if the answer is speed, I simply put my finger over the S. That tells me that distance divided by time equals speed. So I like to write those words. Distance divided by time equals speed, because that tells me the steps to solving the problem. The first step is find the distance. Then I have to divide it by the time. So I have to find the time and then finish the formula, and that's going to give me the answer. So the distance, how do I find the distance? Well, they gave me two positions, so I plot them on the chart. Okay, I already plotted them just to save some time. Okay, so the first position is right here. Okay, I plotted the latitude. Okay, I plotted the longitude, and where those two lines intersected was right there. Okay, then I found the second position. Again, I found the latitude. Okay, 41 degrees 00.4. Okay, and then I found the longitude. Okay, I marked it on the chart. So here are my two positions. Now I need to determine the distance between the position. So here I have my dividers, and I'm simply going to open them up, okay, to the distance between, and then measure that distance. So I'll go ahead, I'll put my dividers on the scale, okay, and it looks like 567.9. So my distance is 7.9. So I write that down. Okay, right under the word distance, I'm going to write 7.9 divided by the time. So they gave me two times. Okay, it says your start time is 2016. So I'll write that down, 2016. And my finish time is 2128. I like to write the big number over the small number, 2128. Okay, so those are my two times, and I have to determine what my travel time was. So to me, I like to just be consistent. So the very first thing I'm going to do is determine what 2128, that's 21 hours and 28 minutes after midnight. But we can't use minutes. We have to turn the minutes into tenths of an hour. So when we do that, okay, the hours don't change, so it's 21 point something. So I divide the minutes, 28 of them, divided by 60, because a minute is 1/60th of an hour. So I have 0.46, okay, so 28 minutes is 46 tenths of an hour, okay. Then I'm going to take the 16 minutes. The hours aren't going to change, so it's 21 point something. So I've got 16 minutes divided by 60 is 0.26. Okay, a little bit more than a quarter of an hour. Okay, 16 minutes, 26 tenths. Okay, so that's the same thing. So now I simply do the math. Okay, I subtract. So 6 minus 6 is 0. 4 minus 2 is 2. 1. So my time is 1.2. Okay, 1.2 hours. Okay, 1.2 hours. All right, now I simply solve the problem. So 7.9 divided by 1.2 equals my speed, 6.58. Okay, I'm going to round that up to 6.6. 6.6 knots, nautical miles per hour. And now I'm going to go to the book and I'm going to see, do I have an answer pretty close to 6.6? Well, there it is. Okay, D says 6.6. So again, it asks what was their speed made good between the two positions. So I used the triangle, I wrote out the formula, and underneath the words I put in the numbers. Okay, so I just solved methodically, okay, to solve the problem.